So transmutation. Transmutation is the second topic we'll be talking about. Transmutation, basically, it's the opposite of decay. So decay, the element is not stable, and then it's emitting energy and turn into another element, new element. In transmutation or artificial transmutation specifically, we hit the element, the stable element, with with a radiation particle and getting another element, new element, and new radiation particle. So this is basically what we call bombarding. The bombarding or artificial transmutation is basically hitting the element, the stable element, with a radiation and getting a new element and new radiation. So this is an example of the aluminum, and it's the same concept. Anything for the calculations and the equations, anything to the right side of in the reactant side on the top has to be equal to the top on the product side. Anything at the bottom side of the left side has to be equal to the bottom side of the right side, and so on. So let's try to practice this one here. So aluminum 2713, aluminum and it was hit by helium, which the symbol has to be known, and we're looking what are the products. So in this case, in the equation, I have also to give you one information from the product side, either the new element symbol or the other radiation that will be emitted from as a product. So in this type, we will say that it's a neutron. So there is neutron emitted in here. Now fill in the space. So here 27 plus 4 has to equal what? Plus 1. Also 13 plus 2 has to equal what? Plus 0. So here 27 plus 4 is 31, which is 30 plus 1. So we have an element with mass number 30, and for the second equation here we have 15. So we go to the periodic table, find out what is 15, and just put it in, which is a phosphorus. Let's try another example. Uranium 238. So uranium 238 and 98, I believe. Let me check. 92 and neutron and electron. And 92 here. And it was hit by neutron and emitted what was it? Electrons too. Electrons -1, 2 of them. Again, if you look here, so if we look here, we would see that 23 98 plus 1 has to equal what? Plus 0. I forgot to write the 0 here. And also 92, 2 plus 0, this one, equal what? Plus minus 2. So let's say 94. So here and here is 2, 3, 9, and 94. We go to the periodic table and get the 94, and the symbol is Pu. So again, another example. So this is the boron 10, not a stable. Sorry, stable. We will hit it by the helium, and we will get nitrogen 13, which is not stable, and a neutron. So this is what we call bombardment, or and it's for producing isotopes. We also call it transmutation. So for example, here is an example. Write the balanced nuclear equation for the bombardment of nickel 58 by a proton. Nickel 58 by a proton, which produce a radioactive isotope and an alpha particle. So you summarize your equation this way, and they need to figure out this element. We will do the calculation as we used to do, and we will find here the mass number is 55, and because there is 4 here, it will make it to 59, and here we have 29 to the bottom, so 27 here and 2 here, and it's cobalt. Study check 3. Now let's take it here and try it. Okay, so same concept, 98 plus 1 is 99. And here we have what? Plus 4. So we got the top part is 95 basically. The bottom part is 43 plus 0 is 43 equal to what? Plus 2. So the result will be 41. So we go to the periodic table and find the 41, and there will be NB from the periodic table. So this is the bombardment, or what we call transmutation. And this is the second topic we talked about. So transmutation. The third topic and the fourth topic are related. They are different but related. So fission and fusion. And you can guess the meaning of each reaction. Fission, breaking down, maybe. Fusion, putting two things together to make a bigger thing, for example. So let's go and see what is fission and fusion. So fission is used in nuclear bombs, and heavy nucleus is splitting by being bombarded with a neutron. So a big nucleus, we hit it with neutron, and it will produce lighter elements and more energy particles. So uranium-235, when you hit it with a neutron, it gives you two new elements, and three particles, three energy particles. Again, same thing. This is uranium-35, and we will hit it with one neutron, and then it will turn into a bigger element that will separate into two elements and three energy particles, or three neutrons and two energy particles as well. So we use these neutrons in actually hitting new nuclei, so they can all keep going on and on and on, and we call this the chain reaction. Um, so like this. So you have a unstable element, a stable element, you will hit it with a neutron, get you two elements and three particles. Those three particles will hit new elements and then divide again into two elements and then three particles, and so on and so on and so on. It keeps going and going and going. That's why the fission reactions are very destructive, because there's always energy released and hit and break down other elements. Um, let's do this later. Fusion. So fusion is opposite. One atom and one atom to make a bigger atom and release energy. So this is actually the hydrogen atom to form the helium in the sun. This is how we get the energy. So the energy from the sun are basically part of it is these neutrons. When they keep hitting, these neutrons keep hitting new atoms. We cannot do this in the lab because it needs to fuse two elements. It needs around this big number, million degree centigrade temperature, and we cannot reach this with the new techniques in the lab, but hopefully we can do that. Not sure why, but it's science, so why not? Um, so the huge amount of science come from fusion of 6 times 10 to the power of 11 kilograms of hydrogen atoms every second. So this reaction happened to around 60 million kilograms of hydrogen every second. So this is the fusion. Let's try to guess these reactions. So let's try to guess. This reaction, what do you think it would be? So element, and then particle, energy particle, then two elements, and then more energy particle. So this is what we just discussed. It's transmutation or bombardment, when you have an element and bombard it with a new element to get different elements. Sorry, this is a fission. Fission. When you hit one element and get two elements and energy particle. How about this element? So an element, and then to the right side you have a new element and alpha. Alpha, then it's alpha decay. An element, and then you have another element and X. So we have to figure out what is the x, and from there we can figure out what is the number. So here is